Welcome students, get ready to solve May-June 0625. This is IGCSE paper 1, which is basically 2-1 code for the IGCSE. This is extended paper, multiple choice paper, and this is variant 1 of extended paper 2025 with TPS. So in this paper we are having 45 minutes, and this is my June 2025 paper of multiple choice question extended paper, and you have to use value of G, that is going to be 9.81 Newton per kilogram. We are having 40 questions in this paper, and total mark for this paper is 40. So question number 1. The speed time graph for a racing car is divided into 4 sections. The sections are P, Q, R and S. The car starts the race but soon crashes into a wall of tires. So might be there is a wall where tires are placed. So this is a wall having tires. So what happens? Which section of the graph show that there is an acceleration that is changing? Acceleration that is changing means change in acceleration is occurring. So this is P, section P. Here no change is occurring because speed is 0. Speed is 0, acceleration is 0. Again here the car come to rest, and no change in speed is occurring, so acceleration is again 0 here. So acceleration is changing at this point Q and R. If you draw the gradient here, you can see here the acceleration is different, here the gradient is increasing, again gradient is decreasing, so here acceleration is changing. And when the point is here, the section is R, again acceleration is changing, so Q and R are possible. So in option A, P, Q, R, S, no, not possible. Q and R is C option, so C is the right option. Moving to question 2, the diagram shows 4 forces acting on an aircraft in flight. So 4 forces, 2 are horizontal and 2 are vertical forces. So let's find the horizontal force, resultant of horizontal force. So resultant of horizontal force is 60 kilonewton, that is acting to the right, minus 40 kilonewton which is acting to the left in the opposite direction. So if you subtract this, the horizontal force, or you can say resultant of horizontal force, comes out 20 kilonewton. What is the resultant force actually? Resultant force, it is sum of 2 or more forces and represented by single force, Now we are going to solve vertical resultant force. Vertical resultant force is 120 kilonewton upwards and 60 kilonewton downwards. We have to solve this, minus 60 kilonewton. So it comes out 60 kilonewton. So if I draw a vector here, 60 kilonewton is vertical and 20 kilonewton, which is less than 60 kilonewton, this is horizontal. It is kilonewton, not newton, kilonewton. So this is the diagram now. Which arrow shows the direction of the resultant of the 4 forces? So as I have written, it is a sum of 2 or more forces. So we have to represent the resultant of the 4 forces. First I solved resultant of vertical forces, resultant of horizontal forces. Now I can see that I have to draw the resultant according to tip-tail method. So it will be somehow like this. So this will be the resultant, tail to tip, tail to tip. So this is going to be the resultant force. So in A option, angle is very small. With the horizontal, it's not possible. Here B, angle is good, greater than the option A. C is incorrect, D is incorrect, so B is the right option here. So dear students, we have to first of all find the two vectors, horizontal and vertical, join them according to tip-tail method, and then you know that resultant will be from tail to tip in diagonal. In diagonal. So we are done with this question. It is a good question. So question number 3. The diagram shows two metal blocks X and Y suspended from identical force meter. These are force meters, Newton they measure force, or you can say weight. X and Y have identical dimensions. When it is written identical dimensions, mean this X and Y is having same length, same width and same height. So it means volume, or you can say area, is same. So here they are asking which statement about X and Y is correct. So you can see weight is different, or you can say force is different. It is having 2 Newton, it is having 3 Newton. So in the option they are saying they have different volumes. No, not possible, because volume and area, I said it would be same, because length and width and height, these are the dimensions, these are same. So this A is not possible, different volume, no. B is not possible, they have equal volume and equal weight, no. One is having 2 Newton, another one is having 3 Newton. So different weight and same volume. So D is right. Question number 4. A girl has a gold necklace. Which apparatus does she need to find the density of the gold? So density is equal to mass over volume. So you know for mass we need electronic balance. We are going to talk about apparatus, and for volume you can use micrometer, meter rule like this. Sorry, for volume we can use meter rule as well, but here it is given measuring cylinder, because gold is going to be, might be in irregular form. If it is regular form, then we need meter rule, or you can say micrometer, otherwise not. So it is not mentioned that regular or irregular shape of gold, so we are going to consider it that gold is in irregular form. So thermometer is not used for the measurement of density, ruler is not going to be used. So we need balance and measuring cylinder, so C is right option here. Moving to question number 5. The spring has length 25 centimeter when load of 2 Newton is suspended from it. So here I am having a spring. It is suspended with 2 Newton. So the length is 25 centimeter. So I say 2 Newton load, length will be 25 centimeter. The spring has length 35 centimeter when the load is 7 Newton. Means if 7 Newton load is attached, this length comes out 35 centimeter. So if 7 Newton is load, so 35 centimeter will be the length. So how much weight is increased, or you can say load is increased? 5 Newton load is increased. And how much extension is occurring due to this 5 Newton load? It is occurring 10 centimeter. Extension is basically change in length. Extension is change in length. So the question is, what is the spring constant of the spring? So we know Hooke's law, F is equal to Kx. Extension is represented by x. So K is spring constant, K is equal to force divided by x. So I take that when extension is 10 centimeter, it means load is 5 Newton. So 5 Newton divided by 10, it comes out 0.5 Newton per centimeter, because length is in centimeter, load is in Newton. So this is B, right option. Question number 6. The diagrams E to H, E, F, G, H shows a block of wood on a frictionless surface. In each diagram, the block has two forces acting on its side. Two forces are acting on side. So which diagram shows the block is in equilibrium? Equilibrium means resultant force should be zero. And even you can say moment, resultant moment should be zero. Or you can say resultant torque should be zero. So dear students, balance, equilibrium means balance force. So I have told you the reason. In this, you can see 2 Newton is acting to the right, 2 Newton is acting to the left. So here you can say a torque, or you can say couple is acting. So this is not a right option. Here two forces are acting but in same direction. Same direction. If you find the resultant, it is 4 Newton, so this is wrong. Here two forces are acting same in magnitude, but opposite in direction. Opposite in direction. So here the resultant force will be 2 minus 2, it will be 0 Newton. If you see H diagram, it is also showing that two forces are acting in opposite direction, having same magnitude. Here the resultant will be 0. So these two are equilibrium. G and H are in equilibrium. So D is right option. Which statement is not correct? So momentum of a system is conserved in all interaction. This is right. Impulse is equal to change of momentum. This is also right. Force acting is equal to change of momentum multiplied by time. This is wrong. It is divided by time. Like this. Momentum is equal to 4. Yeah, C is not correct. Question number 8. A force acting on a moving ball causes its motion to change. This force stays constant. So force which is acting on ball, it remains constant. So now what changes the motion? Mass. If mass increases or decreases, it will change the motion. Because if I am having a heavier ball of 20 kg, if I am having a light mass ball, suppose 3 kg, if I apply 2 Newton here and 2 Newton here, this ball will go faster and this ball will go slowly. So mass is the here main thing, what I think so. So what make the force produce greater change in motion of the ball? So A is decreasing the total mass of the ball. Yes, possible. Increasing the temperature. No, temperature is not dependent. Using a ball with hollow center but same mass. So not going to make any change. Using a different material for the ball so that it has lower density but same mass. Again mass, so A is right here. Decreasing the total mass. So now we are on question 9. A farmer has two carts. The carts have same weight, but one has four narrow wheels. Narrow means this type. You can see this thing. This is narrow. And the other has four wide wheels. So here area is greater. Wide wheel. So I would say here area is smaller. Here area is greater. So the question is, which cart wheels sinks less into soft ground, and what is the reason? So this question is somehow making pressure is equal to force over area. So if greater the area, less the pressure, it means easy to move on the surface. If pressure is equal to F over area and area is smaller, pressure is greater, it is difficult to move on the soft surface. So cart wheels with narrow wheel, that is less area, it is going to have greater pressure on the ground. So reason is narrow, no, it is sink less, it will sink more, not possible. So wide cart wheels and less pressure on the ground, so D is right. Wide means area is greater and less pressure, so easy to move, so there is less chance to sink. Moving to question 10, a hot gas and a cool liquid are at the same pressure. Which row describe the separation and the motion of the particles of a hot gas compared to those of a cool gas? Cool gas, okay. So separation of gas particles is possible when you can say kinetic energy is greater. Kinetic energy is greater, speed is greater, and speed is greater. So separation of gas particles, because it is hot gas, greater than a cool liquid. Yes, possible. Faster than a motion of gas particles faster than a cool liquid, possible. So here it is saying slower, not possible. Faster than a cool liquid, but separation is less, so not possible. This is not. A is right. Greater than cool liquid, separation means moving away, and motion of gas is speed increases because of kinetic energy, so faster motion. Question number 11. A fixed mass of gas has volume 1.2 meter cube and is at a pressure of 200 kilopascal. So I would say this is V1, this is P1. The gas expands at constant temperature, temperature is constant, to a volume of this is V2. What is the new pressure? I say this is V2, P2. So P1 V1 is equal to P2 V2 according to this Boyle's law. Or you can say when temperature is constant, pressure is inversely proportional to volume. We are going to use this. So 200 kilopascal, 1.2 is the volume, P2 is new pressure, so volume V2 is 1.8. So P2 is equal to 200 times 1.2 divided by 1.8. So if you calculate this, it comes out 130 kilopascal. So be careful regarding units. It is meter cubes, kilopascal. So B is right, kilopascal. Question number 12. The specific heat capacity of solid P is greater than that of solid Q. If specific heat capacity is greater, if C is greater, it means more energy is required to raise the temperature. In other words, you can say it will take longer time to attain high temperature. This is the story here. So what does this statement mean? So I have written two options, might be any one of the option is there. Less energy is needed, no. Less energy is needed, no. Less energy is not required. More energy is needed to raise the temperature by 1 degree Celsius of unit mass, okay, possible. More energy is needed to melt, no, not melt, it is raise the temperature, so C is correct here. This is just the statement of specific heat capacity, but in terms that either what effect is going to be there if specific heat capacity is greater than the solid Q. Question number 13. When water evaporates, what escape from the surface of water? Water molecules. Water molecules escape from the surface of water. Suppose here I am having a jar, here I am having water. So from this surface, What will be escaping? Water molecules. So individual atoms, no, not possible. B is right, individual molecules. Question number 14. A sealed container of gas is heated. Suppose this is the container having gas inside it. It is heated. The pressure of the gas increases. Which statement explain this increase in pressure? So what happens? Kinetic energy increases, speed increases of gas molecules, and this gas molecule will hit the wall and it come back. Newton's law, third law is applicable here. Newton's third law is applicable. So it will collide with another gas molecule here, and in this way collision increases. Collision increases. So the force of gas particles striking the wall of the container increases. Yes, force also increases. Possible. This is possible. The force of attraction between gas molecule and the walls of the container increases. Force of attraction with wall it is not possible. With gas particle it is possible. The gas particle collide with each other more frequently. The gas particle collide with each other. Yes, it is possible, but it is also colliding with walls of the container. The gas particle lose more energy. Not. A is appropriate here. Moving to question 15. A student has a copper rod and a wooden rod. This is metal. This is non-metal. Both rods have same dimensions. Okay, same length, same area, or you can say same volume. This is of copper and this is of wood. The student puts one end of each rod into a beaker of crushed ice. Okay, suppose this is a beaker in horizontal form. Here we have a ice. Same is here, that I am having ice here. After few minutes, the student picks up the rod by the ends not in ice. So these ends are not in ice. Which statement is correct? Okay, in metal we have free electrons. In non-metals, free electrons are not present. So in copper, free electron will make it more. Free electrons make it more cooler. Because free electrons make metals a good conductor. Metals are good conductor of heat. If they are good conductor of heat, they are going to conduct this cold as well. So wood is not a good conductor, by the way. The copper rod feels colder than the wooden rod. Yes, because copper is better conductor than wood. Possible. The copper rod feels warmer, not possible. Wooden rod feel colder than no, it is not a better conductor. Wood is a better conductor, not possible. A is right, I would say. A is right. Moving to question 16. The diagram shows a black object X at constant temperature. So this is black object X. The arrow represents absorption and emission of thermal radiation. These are the arrows which represents absorption and emission of thermal radiation. Object Y is at the same temperature, okay, same temperature, constant temperature as X, and is identical except that it has a white surface. So here we have white surface, that is Y. Everything is identical except color. So I would say dark colors are good absorber and good emitter. So it means thermal radiation absorbed or emit by black is better, means by X, as compared to Y. So which row correctly compares object X with object Y? So the rate of absorption for X is higher, rate of emission is also higher. Straight question, simple. The right option is A. Moving to question 17, the diagram shows a cork with a weight attached so that cork floats upright in water. So here is a weight, here is a cork. It can float upright in this water. Transfer waves travel across the water from X to Y. So here transfer waves are going to be present. In which direction do the waves make the cork move? So cork is going to basically move up and down so that energy can travel perpendicular to this. It is a transfer wave. So cork should move up and down. It can be dipper as well. So B is right here. Moving to question 18, a thin converging lens is used as a magnifying glass. So you must know when magnifying glass is going to be used, how does the image compare with the object? So characteristics of image. Characteristics of image. Number one, it should be inverted. Number two, it should be upright, not inverted, upright. Then virtual, and it should be magnified, enlarged. So we are having this D option here, virtual and upright. Moving to question 19, the diagram shows two plane mirrors. One is this, other one is this, at 90 degree to each other. So you can see here we have a 90 degree as well. This one is 90 degree. A ray of light is incident on one of the mirror. So this is a ray of light. The ray reflects off both mirrors before reaching screen. So here we have screen. So reflects off both mirrors. At which labeled point does the ray reach the screen? So we have reflection, so angle of incidence should be equal to angle of reflection. So I am having normal line here which is perpendicular to the plane. You can see this is a normal line perpendicular to the plane mirror. So this angle which is going to be here at my end, it is going to be 45 degree. So you can use protractor. So what I do, I measure 45 degree to the other side as well. So it becomes somewhere here. So this is going to be a reflected ray. It is going to be a reflected ray. Like this. Till the second mirror. So this is also at 45 degree. So now I draw a normal here. This is going to be somewhere here, perpendicular to the plane mirror at an angle of 90 degree. So it is somehow like this. And now again reflection is going to occur at an angle of 45 degree. So it is going to be like this. So B is the right option. This is angle of incidence, angle of reflection, this one. So B is right option. So hope so, dear students, that's fine so far. Now the speed of light in material is 50% of the speed of light in air. So speed of light in air, or you can say vacuum, it is, I name it as C. It is 3 expo 8 meter per second. So speed of light in material, or you can say medium, speed of light in medium or material, I would name it as V. This is 50% means half of this. 50% of 3 expo 8 meter per second. So it comes out 1.5 expo 8 meter per second. So we have to find what is the refractive index. So we must know refractive index is equal to speed of light in air divided by speed of light in medium. So it will be 3 expo 10 power, sorry, expo 8 divided by 1.5 expo 8. So this cancels out. So 3 divided by 1.5, it gives you 2. So refractive index has no unit because it is a ratio. We are done with this question. Question 21. A beam of white light is split into a spectrum of 7 colors. Which name is given to this process? So it is basically dispersion because splitting is there. Moving to question 22. Satellites are sometimes used to receive and retransmit television signals. So which row show type of satellite, okay, and the electromagnetic wave used. So for satellite we use microwaves, or sometimes we can use radio waves as well, but mostly we use microwaves. So it is going to be low orbit, no, not possible. Infrared is not, by the way, option. Low orbit is not, so geostationary, satellite geostationary and microwave. So this is basically the application. So D is right. Moving to question number 23. A sound wave travels through the air and strikes a solid black steel. So here we have a solid black steel. Sound is traveling through air. Some of the sound is reflected from the steel. So sound is going like this. Might be it is reflecting in this way or going in this way, reflecting in this way. And some is transmitted through steel. Some is transmitted. How does the speed and wavelength of the sound in steel compare to the speed and the wavelength of sound in air? You know, steel is solid and air is gas. So speed of sound is greater in solids than air. So speed in steel is greater than in air, greater. So A and B not possible, either it is C or D. Let's see. Wavelength, if speed is increasing, V is equal to F lambda. If speed increases, wavelength also increases. So D is right. Greater than air, greater than in air. So we are done with this question. The diagram shows a bracelet containing two magnets. Question 24 we are doing. The arrows represent the pattern and the direction of magnetic field due to the magnets. Which row identifies the magnetic poles at J, the magnetic pole at K, okay, where the magnetic field is the strongest? Where is the magnetic field strongest? Okay, first of all you have to remember, dear students, from north to south magnetic field moves. From north it originates and terminate at south. So here it is terminating, so J is most probably it is going to be north. So here again it is going to be north because it is originating from here. So C, D are not right options. So either it is A or B, but where is the magnetic field is the strongest? So you know here repulsive force is present. Repulsive force is going to be stronger. So we would say at X, no, it is going to be greater where the lines are closer. X is also there. Yes, it is here. So here at Y repulsive force, yes, no doubt in this, repulsive force. And at X you can see lines are very closer to each other. So at this point magnetic field is strongest. So A is right here. Moving to next question. Which row describes an electric field and its direction? Okay, electric field always originate from positive terminal and terminate at negative terminal like this. So its direction is from positive to negative. So description is given, region in which an electric charge experiences a force. Yes, here electric force is present. Direction of electric field is direction of the force on positive charge. Yes, possible. So let's see another option, region in which electric charge experiences a force, direction of the force on a negative, no, negative charge is not going to be either, it is going to be positive. So produces a current, no, only A is right, because region in which electric charge experience what? Electric force, not current. So direction of electric field is direction of the force on positive charge, positive to negative. Moving to question 26, copper wire is available in fixed lengths but in various diameters. Each wire has a different resistance. Okay, resistance is directly proportional to length. So length is fixed, so it means various diameter, it means area is different, so resistance is inversely proportional to area. If area increases, resistance decreases. So which relationship between R and D is correct? So we have to tell about this relation. So you know R is equal to 1 over area is equal to pi R square, which is going to be pi, radius is d by 2, half of diameter, d by 2 and its square. So it would be pi d square and this. So they are inversely proportional to the square of diameter. So it is d not, r is inversely proportional, no, not possible, r is inversely proportional to square of d is right. Okay, students, we are now on question number 27. Question number 27 says the diagram shows three 20 ohm resistors R1, R2 and R3 and a switch S connected to a DC power supply. So here is a DC power supply. The switch S is open. It is open, so it means this branch is not going to be considered. You can assume that here we have no branch. The potential difference across R3 is 9 volts. So here the potential difference is of 9 volt. What is the potential difference across R3 when switch S is closed? Okay, when this S switch is closed, what will be the voltage here? What will be the potential difference across this? But before that, let's see what is the potential EMF here, EMF. So what I'm going to do, I'm going to redraw the circuit. Here I'm having positive terminal, here I'm having negative terminal. Here this R2, which is in series with R3, because this is the only path at the moment, single path. So R2 in series with R3. So all the resistors are of 20 ohm, this is 20 ohm, this is 20 ohm, and when the switch S is open, here we have voltage 9 volt. So across R2, the voltage is also 9 volt, because same resistance, same resistors, or and series circuit. So what is going to happen? Potential difference will be same. So here it is a series circuit, so EMF is equal to potential difference across one resistor plus potential difference across another resistor. So here it is 9 volt plus 9 volt, this EMF is 18 volt. 18 volt. Okay, now the switch is closed. So if we see this circuit again, what is happening here? When the switch is closed, these two resistors are in parallel with each other. Now these two resistors are connected parallel to each other. So we have to solve their resistance. 20 ohm, 20 ohm, same resistance and connected in parallel. I have told so many times in previous papers and in the electricity topic that when two resistors are connected in parallel with each other, and having same resistance, their resistance become half. So it will be 10 ohm. So if I draw another circuit here I'm going to have R1 parallel to R2, then another component R3. This is the circuit now. So it becomes 10 ohm and R3 becomes 20 ohms. If you forget that two resistors connected in parallel having same resistance, their total resistance will be half. You can calculate it by formula as well. 1 over R2 is equal to 1 over R1 plus 1 over R2. So 1 by 20 plus 1 by 20. Then you have to take the reciprocal of this whole after simplifying. So it will be 10 ohms if you solve this. So this 10 ohm total resistance now in series with 20 ohm. So here we know 18 volt is the potential, EMF. So we can apply, it is a series circuit, we can apply potential divider concept here. This is a very good question, by the way. One way is this, other way is that you solve them, then find the current flowing here, and then you can find the potential difference or voltage across this. But first I'm going to do by this method. I will be explaining both of the methods. So in potential divider, what is happening, output voltage is equal to resistance across which you have to find the voltage, or you can say potential difference, divided by both of the resistors which are connected there in that series circuit. So R1 and R2 parallel plus R3, and it is going to be multiplied with input voltage. So this come out 20 divided by 10 plus 20 multiplied by 18. So 20 divided by 30 multiplied by 18. If you simplify this, it comes out 12 volt. So C is the option. This is very simple one, but the question is little tricky, but this is the simplest method. If you find current, this is going to have one more additional step, that you have to find the current. So before that you have to solve their total resistance. This will be 30 ohm. So I is equal to V over R total. So 18 divided by 30, this will be the current. You can simplify if you want. It will be 2 with 9, 2 with 15, then 3 with 9, 3 with 5. So it will be 3 by 5 ampere. But we have to find the voltage here. So you are going to apply now V is equal to IR. So calculation is increasing. When the steps increases, calculation error, chances of calculation error increases. So 3 by 5 times 20 ohm. So 5 with 1, 5 with 4, it comes out 12 volt. So the result is same. Moving to question 28, the circuits shown all include a DC power supply, one diode, two light emitting LEDs. In which circuit will both LEDs will be turned on? So both LEDs be turned on. So symbol of diode is this. You must remember the symbol of diode. DC power supply looks like this. Then two light emitting diodes. Light emitting diode symbol is this one. So if both of them want to be turned on, it is a series circuit, so they must be connected in series like this somehow, like this, then like this. Here it should be a positive terminal, here it should be negative terminal, like this they should be connected. So in A option, if you see positive terminal, current is flowing like this. So from here current will not flow, it is connected in reverse bias, or you can say reverse order. So it is wrong. If you see B, diode is again connected in reverse order, so induction is not going to occur, so this is also not going to glow. So wrong option. Here current is flowing, it is in series, yes, C is right. They are connected in right way. So in D option, you can see both of the LEDs are again connected in wrong order. So only C is correct here. Moving to question 29, a wire connected to a resistor R is moved in a magnetic field. Magnetic field is from north to south. So it is left to right. You can place your first finger in this pattern. First finger towards right. A current is induced in the direction shown. In which direction the wire will move? Force, or you can say motion of wire we have to detect. So current is induced in the direction. Current is induced means you can see current is towards you. So second finger should point towards you. Second finger towards you. And these both fingers must have 90 degree between them. And current is induced, so we are going to use Fleming's right hand rule. Fleming's right hand rule. So thumb will point direction of motion, or you can say direction of force. So if you use Fleming's left hand rule, so here thumb will point downwards. Thumb will point downwards. So C is right. Here the motion of wire will move downwards. C is right. Moving to question 30. Which component is not found in an AC generator? Okay. Coil of wire, yes, it is right. Split rings, commutator, no, it is not present, so it is present in DC motor. So B is right. Magnetic poles are there, slip rings are there in AC generator. Not found, that is split ring. So there, question 31, there is a current in a straight metal wire in the direction shown. Okay, so we have a wire, or you can say conductor, current flowing in the upward direction. This is a conductor. Which row describes the direction and the pattern of magnetic field? Direction of magnetic field and pattern of magnetic field due to the wire when looking from vertically above the wire. So you have to use here right hand grip rule. Right hand grip rule. So thumb will point in the direction of current. In the direction of current. Direction of current. Curl of fingers point what? Direction of magnetic field. Direction of field. So it is going to be this way, circular, and direction is anti-clockwise. Direction will be anti-clockwise. So this is going to be the path here. So A is right option. Direction is anti-clockwise, pattern is circular. Other options are not right. Question 32. A simple transformer contains iron core. Iron core. What is the function of the iron core in the transformer? Function of iron core is to link magnetic field between primary coil and the secondary coil. So we have to see this option. To conduct current from primary, no, current is not going to be conducted. To enable secondary coil to act as an electromagnet, no, it is iron core. Iron is a soft magnet. To ensure high voltage between, no, voltage is not going to be there. To link the magnetic field in the primary to the secondary coil, yes. Then what happens, flux will be produced and EMF is going to be induced. So D is right. Question 33. In an alpha particle scattering experiment, a beam of alpha particle is fired at a very thin piece of gold foil. So if you remember, we have discussed this thing, that we have a protons, or you can say we have an atom having nucleus with positive charge. So alpha particle also have positive charge. The beam which is passing between the two atoms, it will pass straight. Most of the alpha particles pass straight. Few of them bend at an angle which are going to be very near to the nucleus, and which are coming in front of the nucleus, they bounce back, and they are very few. So in which direction do most of the alpha particles? Most of the alpha particles, so straight they pass, A is right. Moving to question 34, an atom of boron contains 5 protons and 5 electrons, so they should be same. The nucleon number of the atom is 11. So how many neutrons are there? So you know nucleon number is sum of proton and neutron. So if you solve 11 is equal to proton is 5, you can find neutron, it will be 6. Moving to question 35, a detector placed near a radioactive isotope, it gives a measured count rate of 800 counts per minute. 800 count per minute, okay. So this is detected by the detector. The half-life of the isotope is 3 hours. So it means after 3 hours, count rate will be half. The background count rate is 32 counts per minute. So you have to subtract 32 from this. So if you subtract 32, the corrected count rate will be there. Corrected count rate of isotope will be there, which will be 768. Yes, because radioactive isotope is having a count rate. Background count rate is not going to be half, it is fixed. So what is the count rate on the detector after 6 hours? So 6 hours means number of half-lives are 2. Number of half-life is equal to 2. How it comes? Because it is equal to total time divided by one time of one half-life, so it will be 2. So we have to half this 2 times. 768 divided by 2, it will be 384. Then make it half once more. So after 6 hours it will be 192. 192 count rate will be there of isotope, but we have to tell that what count rate on the detector. So detector is going to consider both this count rate plus the background. So it will be 192 plus 32. It will be 4. Then it will be 20, 12, 24, 224. So count rate per minute. C is right option here. Sodium 24 is a radioactive isotope that emits beta radiation. Which nuclear equation show how sodium 24 decays? So nuclear equation, it means beta decay equation is going to be there. In beta decay equation, what happens? One neutron changes to one proton plus one electron. So nucleon number will remain same. Nucleon number remains same, it will not change. Proton number will increase by 1. Increase by 1. So you can see A option, sodium having nucleon number 24, proton number 11. It changes to magnesium. So from 11 to 12, this is proton number increases by 1, nucleon number is same, and 1 beta decay, 1 electron. So A is right option here. 37. Which safety precautions must be taken when using a source of gamma radiation? Okay, first is that reduce the distance between source and person. No, it is wrong. Reducing the distance means you are increasing the chance of radiations, exposure to the radiation. Reduce the time of exposure to the radiation. Yes, possible. Use a suitable shielding material between source and the person. Possible. 2 and 3. So D is right option. Moving to question 38. A student defines 3 periods of time. The time T has taken for the Earth to orbit the Sun, it takes 365 days. Time TR taken for the Earth to rotate once on its axis, it is 24 hours. Not days, it is hours. So, because it is tilted at an angle of 23.5 degree. So the time TM taken for the Moon to orbit the Earth, it is 28.5 days or 29 days, you can say. approximately. Which row shows the shortest period of time? It is 24 hours. Longest period of time is 365. So it is TS and this is TR. So B is right here. B is right. Question 39 now. Which statement about the universe is correct? The universe consists of 100,000 galaxies. No, it's wrong. 100,000 is basically the diameter. So here it is billions of galaxies. Wrong option. Redshift is a decrease in the observed wavelength of electromagnetic radiation emitted from receding stars. No, it should be increased. It is also wrong. Light emitted from distant galaxies appears redshift. Yes, possible. Redshift of the light from the distant galaxies gives evidence that universe is no, it is expanding. So this is wrong. So C is right option. Which statement about the cosmic microwave background radiation is correct? So frequency is decreasing and wavelength is increasing because this is going to be a radiation when Big Bang basically occurring. Big Bang occurred. And now its wavelength is increasing. So CMBR has a frequency higher than that of infrared radiation. No, its frequency is decreasing because universe is expanding. Universe is expanding. If universe is expanding, it means wavelength is decreasing. If wavelength is decreasing, sorry, wavelength is increasing. If universe is expanding, wavelength is increasing, distance is increasing, distance is increasing. So wavelength will be greater, frequency will be smaller because V is equal to F lambda, V divided by F is equal to this. So if wavelength is increasing, frequency should be less. So CMBR always had exactly same frequency. No, CMB had a shorter wavelength in the past. Okay, in the past, universe started from a point. At that time, wavelength was smaller, frequency was greater. And as universe is expanding, so what is happening? Wavelength is increasing. This is right. CMBR was produced a long time after universe was formed. No, it was formed at the same time due to the reaction. So C is right here. So we are done with this question 40 and with this paper. So the paper is IGCSE 0625, paper 21, June 2025. If you have any question, any doubt in this paper, any question which is not clear to you, you can contact me. Thank you. Stay blessed.